Okay, we're going to start 8.2 by talking about the difference between intersection and union. Okay, so consider these two sets where A is 1, 2, 3 and B has the elements 2, 3, and 4. Okay, the set of all elements that belong to both A and B. Now, most people think of when you say A and B, they say, oh, it's 1, 2, 3, and 4, right? A and B. No. And means it's got to be an A and it has to be in B. Is the number 1 in A and in B? No. The number 2 and 3 is in A and B. So that's called the intersection, right? Where they overlap. And the English word is and, the math word intersection. And here's the math symbol. Now union means all of them. Think about an intersection as the intersection on a road, right? It's only this part where those roads overlap, intersect. This isn't in the intersection. This isn't in the intersection. Think about a union like as a marriage, right? That's a union. And if you have a family and you're marrying someone with a family, then in your union, you're all together. So the union is all of them. But the English word for that is or, because it means, hey, I want the numbers it can be an A or they can be in B. Not and, or. Is 1 in either A or B? Yeah. Is 2 in either A or B? Is 4? Yeah, they're all in A or B. And here's the symbol for union. So if you're trying to think about the symbol that goes with the term, if you're using and or, this symbol you can make like a little A for and. So the other one is or. If you're using the term intersection and union, this one for union looks like a U. So the other one's intersection. All right, so maybe that'll help. Okay, here's just some more explanation. The intersection, and that's a better symbol for intersection. Those others were a little bit flat, right? They're as tall as your variables. Is the part where they overlap. This part that's in A, but also in B. And the union's everything. Okay, so if we're trying to find, if we're trying to find the intersection of two sets, that's and, right? So I want only the numbers that's in A and in B. Is 3 in A and in B? No. Is 4 in A and in B? No. 5 is in A and B. 6 is in A and B. That's the intersection of those sets, the elements that's in both sets. If we're doing a union, right, that's an or. So A or B, that's all of them. Because it can be an A or B or both, either one, both. So 3, 4, 5, 6, 7, all of them is in the union. All right, so why we're interested in those terms is we're going to have compound inequalities, which means two inequalities that's linked together with the words and or. Right? Okay, so here's an inequality. You can have x plus 1 is less than or equal to 9, and also x minus 2 has to be greater than 3. Or you can have the answer to this or that. And all you do is you solve each one individually. This is a little confusing. Let me put a line through here. Right, these don't go together. These go together as one set, and these go together. So you'll only have two at a time connected with an and or an or. You just solve each inequality, write your interval notation, and then if it's an and, you'll put that between them. If it's an or, you'll put that between them. Right? That's adding to our interval notation is all we're doing. Okay. And there's the steps. If you want to pause it and read through that. Once again, we're just going to dive into it. Okay, solve the compound inequality and graph the solution set. And I'm going to write the answer in interval notation. Right? Okay, because we need that. I'm not sure why it's not on here. Okay, so I'm going to solve each inequality first. So I need to subtract 3, which means x is less than -2. And if I add 4, x is greater than -8. Okay, so let's graph each one individually. X is less than -2. So here's -2 pointing this way. Okay, greater than -8 pointing this way. Okay, maybe I should have gone a little. Let me go a little farther here with my line. Okay, now greater than -8. Okay, so here's my inequality solution, but on here, only the part where they intersect. So in other words, this part right here, where they overlap, where both of them have parts of the solution, is my answer. So my final graph, I would need to get rid of these bits because that's not part of my answer. My final solution looks like that. And my interval would look like -8 to -2. Okay. Let's try it again. Okay, have 2 inequalities, this time joined with an or. I really don't, until I'm graphing it and writing my final interval, I don't care if it's an and or an or. I'm just going to solve each one individually. So x is greater than 3, or, okay, I got to put all my x's on the same side here first, or x plus 5 is less than 6. So x is less than 1. All right, so now let's graph this. Greater than 3, here's 3, greater than, parenthesis, because it doesn't have the equal. Okay, and less than 1, but the arrow's pointing this way this time. Okay, but because it's an or, it means, hey, it can be this stuff or that stuff. Either one, this or that. So my interval notation would look like -infinity to 1 with a parenthesis or 3 to infinity. Notice really when we have an and like we did last time, because of what and means, and is their overlap, I'm never really going to use that and symbol in my interval notation because I'll have just one interval because it's the stuff in this one and also at the same time in the other one. But with the or, right, it can be either one. Oh, it can be over on this side or on that side. It just can't be in here. Okay, let's try it again. Subtract 4x from both sides. I don't know why it changed colors. Well, obviously I accidentally hit something, but doesn't matter, does it? Negative 2x less than or equal to 8. Now careful, dividing by a negative, multiplying or dividing by a negative, right, changes the sign of the inequality. Then I have an and. This is not dividing by a negative, so the sign does not change. Okay, so negative 4 facing that way, and it's a bracket this time because we have the equal part. And greater than negative 3. Okay, so a bracket again. Actually, let me do that one just so for emphasis. This one in a different color. And remember, because it's an and, it's only where they overlap. In other words, where I have blue and red on both of them. So for my final graphical answer, it doesn't look like this. I've got to decide, hey, what's the final result look like? And this part right here isn't in both of them. It needs to go. Okay, so that's what my final answer looks like. So if I want to write that in interval notation, it's negative 3 to infinity. Yeah, with the and, we don't ever really have that and symbol in our interval notation because it's the overlap. I will just have one interval where both problems have solutions. Okay, we've got an or now, so let's try this. Let's add 2 to both sides. So 3x greater than or equal to 15. Let's divide by 3, just getting that x all by itself. X is less than or equal to 5. Or let's subtract 5 from both sides. Or x is less than or equal to 2. Okay, less than or equal to 5. Here's the 5. The arrow's facing this direction. Less than or equal to 2. Here's the 2. Again with the arrow facing this direction. But because it's or, it means, hey, it can be either one of these. Right? Does not have to be both on an or. Either one or both. So my final graph looks like this. And my final answer in interval notation, I know this one's an or, right? But I still have one interval. I don't have to have 2 with the or, but I can have. Whereas I'm not going to have with the and. One more. Okay, let's subtract 2. So we have x is greater than 1. It's an and. Let's subtract 1. 2x is less than negative 4. X is less than negative 2. All right, one at a time. X is greater than 1. Here's 1. Parenthesis. Okay, x is less than negative 2. Here's negative 2, and the arrow's facing this way. Okay, it's an and. I have to have their overlap where they intersect. Only parts where both equations have a solution or an answer, and there's not any intersection. There's not any overlap. Oh, well, then there's not any answer. All right. So I could still have a no solution or an all solution. If I wind up with an arrow going both ways and covering everything, then it's all real numbers. But if I don't wind up with any overlap, there's no solution. Okay, let me know if you have questions.